Now we're going to represent a function as a table, and then once we get the table finished, we're going to translate that down to a graph. So the problem we're going to use is this. Let's suppose you join a health club, and let's say it costs $100 to join, and then it's $20 a month. Let's make a table of values that would represent the number of months versus the total cost. So 0 months, that means that you've just gone and you've signed up, right? So you just went and you joined. You haven't paid any $20 a month because you haven't been there long enough. So your cost would be $100, just a straight $100 at 0 months. Then after a month, you would have paid $100 plus you would have had to pay for 1 month that was $20. So 100 plus 20 would be $120. That's how much you would have paid so far for 1 month, $120. Now if it was 2 months, you'd have your initial $100 plus 2 months at $20 a month. That would be $140. Like the total cost that you have put into being at the gym. Then for 3 months, your total cost would be the 100 plus 3 months at $20, and that would be 160, etc., etc., etc. So the idea is to start to see if we can develop a pattern. So at first we were at 100 plus nothing, then 100 plus, and you see how I wrote it? It goes 1, 2, 3, and then inside the parentheses is always a 20. So the 100 seems fixed, the 20 seems fixed. Apparently what varies from line to line is just this number, the 1, the 2, and the 3, which is the number of months. So if we let the number of months be just some generic n, if I follow the pattern, it sure looks like the cost would be 100 plus n times 20. So we could write that the cost is 100 plus maybe 20n looks a little better, or you could write it like this, 20n plus 100. That's fine. Addition is commutative, so either one is fine. But that's how we could write the equation with 2 variables. So that's representing the function as a table of values. And it helps you determine the pattern so that you can write out the function as an equation, and then we can graph it. So if we have a table, it's a table of values that would land on the graph. So then we can just plot those points and then draw our graph. So what I've got on my graph is we're just really looking at just this first quadrant. So we have on the x-axis you put the independent variable. The independent variable is the number of months because you can go for as many months as you want. But the cost that you pay, the total cost, is going to depend on how many months you were there. So that's why cost is the dependent y and number of months is the x. All right, so in order to draw these, I might need to zoom out a little bit. At 0 months, which would be right here, we paid $100, right? So I'm going to put a dot up here at 100. So that's when I just signed up. Then after 1 month, I'd paid a total of 120. So put a dot there. After 2 months, it was 140. After 3 months, it was 160, and you should be able to see the pattern by now. You don't have to keep plotting points. The whole idea is that you realize this is a line, and then you can just get whatever ruler you have and line up your dots. And then you can draw a line that represents the total cost. And this line, cost is 100 plus 20 times however many months you're there. And so it goes on forever. So then what you could do if you wanted to know how much your total cost would be at 6 months, if you drew your line long enough, you'd be able to read up on the graph and then tell what your total cost would be. And if they would prorate things, like if you were there for half a month or part of a month, then you could see how much the total cost would be if they were prorating the cost. But anyway, we're just going to be graphing basic straight lines in here, nothing too fancy. So being able to translate a table to a graph is definitely an important skill.